probability and odds before. Okay. Mathematically, they're not the same thing, even though people in the world kind of use them as the same thing. Probability is kind of more of a percentage on how likely something is to happen, whereas odds tell you basically if something is more likely to happen versus more likely to not happen. I don't know if that makes sense, but it might make sense more when I explain it. So probability, it's a ratio of the total number or total possible successes to total possible outcomes. Okay, so let's say
Is this like when you have like a bag of marbles?
yeah. This is exactly like that. So yeah, let's say you have a bag of marbles and you want to pull out either a red or a blue one. Well, your successes would be the total number of all of the red and all of the blue marbles in the bag. That's successes, what you want to happen. And then the possible outcomes would be the total number of marbles in the whole bag, all colors put together. Okay, and that's the sample space. The sample space is the total number of all possible outcomes. Or in the case of like marbles in a bag, it's all possible objects. Okay. Now, if all the different, like let's say you're talking about marbles in a bag and colors, and all of the colors, they're the exact same numbers of colors, like so there's 5 red, 5 blue, 5 green, 5 yellow, 5 whatever, they're all the same number, then that means they're equally likely to happen. So equally likely is when all probabilities are the same. So if I had, well, let's say 5 red, 5 blue, and 5 green marbles in a bag. They're the same number of marbles, the same number of total marbles. So I'm just as likely to pick out a red or a blue as I am a green, because they're equal. Probability is always between 0 and 1. It relates to percentages. So you cannot have a 1 is the same thing as 100% likely. So you can't have something be more than 100% likely to happen. That's not possible. Does that make sense? So when they talk about chance of rain on the news, that's a probability. Like if they say there's a 76% chance of rain, that means it's 76% likely that it will rain, but you can't have more than 100% likely that it will rain. I mean, even if it's currently raining right now, that's only 100% likely to rain. Does that make sense? Okay. All right, so to find probability, you count up the number of successes or favorable outcomes, and you put that over top of the total number of possible outcomes. So if you have a pair of dice that's two dice, a single die is a die, just one. So if we find the probability of rolling a 1 or a 5, see this is 2 possible outcomes, a 1 or a 5. So favorable is 2. The total number of possible, right? There's 6 sides, 6 numbers. So that's 6. So our probability is 2 over 6. But we want to reduce it. So both 2 and 6 will divide by 2. So it gives me 1 out of 3. If I turn this into percentages, that's a 33% chance that I'm going to roll a 1 or a 5. Okay. My probability of rolling an even number, there are 3 evens, right? 2, 4, and 6, and then 6 total. So my probability is 3 over 6. Can reduce that by dividing by 3. And so that gives me a 1 in 2 chance of rolling an even, or 50% chance. If you have a favorable outcome, that also means you have unfavorable, right? They complement each other. So the complement to the favorable outcome is the number of unfavorable outcomes. So if we're looking at the die example from back here, rolling an even, let's do rolling a 1 or a 5. There would be 2 favorable and 4 unfavorable. So that these 2 and the 4 complement each other. And the complements will always add up to the total number of possible. So usually it's associated with the word not. Like, so if I want blue, the complement of blue chips would be not blue. Okay. So to figure out these probabilities, first we have to take up the total number of chips. So there's 5 red, 7, so that's 12, 18, 28. So 28 total. Okay. There are 7 blue, so the probability of pulling out a blue is 7 out of 28, which will reduce to 1/4.
Do you always have to reduce?
Yeah, you want to reduce if it's possible. It's just a 7 in 28 chance, it doesn't, for a lot of people that doesn't mean a lot, but a 1 in 4 chance means a little bit more. Like for every 4 times I pull something out, it's likely that one of them will be blue. So it means a little bit, it's easier to use, yeah. Okay, red or yellow, right? Because yeah, I've got 5 red and 6 yellow. So that's 11 total. So I've got 11 over 28, which I can't reduce. So that's my probability of picking red or yellow. Okay, not green. Yeah, if I have 10 green, there's 18 that aren't green. So my probability of pulling out not green is 18 over 28. Both of these I can reduce by 2. So 9 out of 14 will not be green. Okay, this is one way to okay, so tree diagram is just one way to determine total possible outcomes. Okay, it's not necessarily, well, it's not the shortest way. It's just, it is a way. It's very visual, so for people that are visual, it's helpful. Okay, so what we do is we have baseball caps come in blue, yellow, or white, and they can either have the mascot or the initials on it. Okay, so we're going to make 2 columns for color and design. Okay, so we can have a blue, a yellow, or a white hat. And if we go with blue, we can get a mascot or initials, right? If we go with yellow, we can get a mascot or initials. And if we go with white, we can get a mascot or initials.
So 6 outcomes?
So yeah, so there's...
So all you really have to do is like pretty much multiply the whole thing?
That's the next page, yep. So there's 6 possible outcomes or 6 possible hat combinations.
Would that work for like everyone? Like if there's, so all you gotta do is multiply the numbers of colors and then the numbers of other things for it?
Yeah.
Really?
Yeah. Because see, if we think, let's say, okay, if you could do blue, yellow, or white with a mascot or the initials with either, you know how some baseball caps have mesh and some have fabric? Well, you'd add two more. So you do like a blue with a mascot with mesh or fabric. A blue with initials with mesh and fabric. So you'd be multiplying times 2. Which brings us to the fundamental counting principle. Now this is really a fancy way of saying if I have 3 colors and 2 designs, 3 colors, 2 designs, I multiply them together. So if we have an ice cream shop that offers 1, 2, or 3 scoops of ice cream, that's 3 possibilities for scoops, right? So we have 3 possibilities for scoops. This is supposed to say flavors. I don't know what a flaker is. There's 12 flavors. And then we can have a wafer cone, a sugar cone, or a cup. So that's 3 containers, right? Those are our choices. Now to find out how many total possible choices of ice cream there are. Now you would not want to make a tree diagram for this because there's 12 flavors, right? That would be huge. So we take our scoops times our flavors times our amount of containers, and we get 108 possible orders. So if you were to go order a different combination of ice cream every single day, it would take you 108 days before you ran out of possibilities and had to start over. Because you could order something different every day for 108 days. Same thing with digit passcodes, you know, for like the cars that they have those now keyless entries, and you can get them for your front door and all kinds of things, and you think, oh, well, those can't be very secure. But look at this. 3-digit password. Most of them are longer than 3 digits, right? But if we do just a 3-digit password, the password can be any digit 0 to 9. So this is 10 possible, right? Because we have to count the 0. But the digits cannot repeat. So if we have a 3-digit code, the first digit, we can choose any one of the 10. The second digit, we've used one, so how many do we have left to choose from? And then the third digit, and if I multiply those together, I have 720 possible combinations. Okay, and that's just with a 3-digit code. Imagine if you can pick a 7-digit code, and imagine if you're allowed, if I was allowed to repeat numbers, I could do 10 times 10 times 10, which brings me up to 1,000 possible combinations. If I have a 7-digit code that I can repeat numbers on, that's 10 to the power of 7, which is 10 with 7 zeros after it, which is 10 million. If you have a 7-digit code and you can repeat numbers, there are 10 million possible combinations of numbers that can be used. That's why these things are relatively secure. Now, could somebody guess your combination on the second try? Sure. But they're really going to sit there and go, okay, I'm going to try all 720 of these possible combinations until I get into this thing. Not likely. Okay, any questions on this one? Fundamental counting principle? Okay. Odds. Ratio of success to failure. Okay, probability is the ratio of success to total possible outcomes. Odds are the ratios of successes to failures. So if we have the odds of rolling a number less than 3 on one single die, two successes, how many failures?
6.
Failures. There's 6 total.
Oh, 4.
Yeah, so 4 failures. So the odds are going to be 2 over 4 or 1/2, 1 to 2. Okay, probability was 1 over 6, or 2 over 6, which is 1/3. Okay, so there's a 33% chance of rolling a number less than 3, but your odds are that every 3 times you roll, you'll be successful once and you'll fail twice. That's what this is telling you. You'll be successful once and you'll fail twice. The nice thing about odds is, if your numerator is greater than your denominator, that means your successes are higher than your failures. These are good odds. If your numerator is less than your denominator, these are bad odds. Okay? These are bad odds. This is saying if I roll the dice 3 times, 2 of those 3 times I'm going to fail at getting a number less than 3. You wouldn't want to gamble on this, right? That's why odds are a little bit more specific than probability. Probability tells me I have a 33% chance of rolling a number less than 3, but odds tell me that every 3 times I roll, I'm going to fail twice. Does that make sense? It puts it a little bit more in perspective. They're telling me the same thing, kind of, but this puts it more concrete. And also, if your odds, because your numerator can be greater than your denominator, odds aren't limited. Probability is only between 0 and 1. Odds can be, like if you have, say, 10 possible outcomes and 8 of them are successes, you can have 8 over 2, which makes you 4 to 1. So you're better than 1. Questions on that? It's freezing in here. Okay, we're not gonna start section work.